Okay, good evening all. So in the last couple of lectures, we looked at different kinds of operators. We also briefly looked at if else. We will look at that also today. But in operators, there is something more which we need to discuss. Usually, you know how to deal with different operators when they come alone. Like for instance, when you look at an addition operator, you know you need to do addition. When you look at a modulus operator, you know you need to do modulus. Whatever it is, be it logical operator, logical AND, or bitwise AND, whatever they are, you know. But what happens when many of these operators come together in a single expression, right? So let me just give you an example. Suppose if let's start with simple examples. 5 plus 7 plus 8. How much is it? How much is it? 20. Simple. You add these two, then this. All right? Or you add these two and then this. It doesn't matter. But what if I have to do 20 minus 15 minus 2? Is it 3 or 7? Why 3? Huh? Should I do this subtraction first or should I do this subtraction first? Left one first. How do you know? Huh? You know that in school. Okay. Yeah, that's correct. You have to do this subtraction first and then this subtraction next. So 20 minus 15 is 5. Then 5 minus 2 is 3. Alright. So this is 3. Okay. Now, suppose 20 plus 5 times 4 minus 8. What is this? Huh? 32, right? Which one should you perform first? So this you should perform first. Then addition. Then subtraction. All right. So this is 20. 20 plus 20 is 40. 40 minus 8 is 32. Okay. Now 20 divided by 8 plus 4 into, or let me say 8 into 4 plus 3 by let me say plus 6 by 3. Okay, what is the value of this one? 20. 20 by 8 is? This is integer division or real number division? Real number division. Where is real number in this expression? It's integer division. So 20 by 8 is 2. Whatever it is 2 point something, that doesn't matter. It is integer division. So you just need to take quotient. 2 into 4, 8. 8 plus, you can't do 8 plus 6, right? You should first perform this division. That is 2, right? So 8 plus 2, 10. So here, so should we perform this division first or this multiplication first? Division first. Why? Board mass. Yeah, that is mnemonic for remembering. you will see it becomes a little more complex when we include other operators also. All right, so these two operators like multiplication and division, they are of same precedence. All right, they are of same power. So if two operators are of same power, then how do you decide which one to perform first? Whichever you see first, you perform. So from left to right, whichever operator comes first, you perform that. If two or more operators are of the same precedence. If one operator is of a higher precedence than another operator, independent of the position of the higher precedence operator, you should perform that first. Right? For instance, in this case, multiplication is of higher precedence than addition. But addition came first, but you did not perform addition operation first because addition is of a lower precedence than multiplication. So wherever multiplication comes first, all those multiplications should be performed before you perform additions. All right? Or wherever division comes first, all those divisions should be performed before you perform addition. Okay? But if multiplication and division come together, both are of same precedence, then what do? Whatever comes first from left to right, you perform that first. So operators can be of different precedence or can be of same precedence. If they are of different precedence, perform the higher precedence operations first, then the lower precedence operations. If two or more operators of the same precedence come, then perform left to right. Okay, simple. So, so in this case, this will be performed first, then this will be performed second, then this will be performed third, finally this will be performed fourth. Okay, simple. So, multiplication and division, they are of same precedence. All right. So if they are of same precedence, how do you resolve them? Left to right. And then addition and actual multiplication, division, and modulus operation. These three operations are of the same precedence. Okay. And then addition and subtraction, again they are of the same precedence. Again, you perform left to right. Okay. But these two operators are of a greater precedence than these two. I mean, these three operators, multiplication, division, and modulus, they are of a greater precedence than addition and subtraction. Okay, this is simple mathematics which you already know. Fine. Now, same logic you sort of need to expand to programming operators, where we have different kinds of operators: arithmetic operators, logical operators, relational operators. We discussed all those, right? Now, all these operators will have some strict hierarchy, some strict precedence. So some operators are of a higher precedence, some other operators are of a much higher precedence, right? There is a long hierarchy of precedence of operators. Now, if two or more operators are of the same precedence, you go from left to right most of the times. But for some operators, you need to calculate from right to left. Can you name one such operator? We discussed an example. So from the example, you need to guess which operator that is. Which operator, when you see two or more instances of that operator, you perform the operation not from left to right, but from right to left. First perform the rightmost operation, and then the next operation, and then the next operation, and so on. Huh? No, not logical. Binary? All these are binary operators. Many of them, most of them. No, that's not operation. What he's saying is when we convert decimal to binary, we get the remainders and then we go from bottom to top, that kind of a thing. No, that's not operation. That's just writing sequence of digits in one order. Where is the operation there? Huh? Modulus is this left to right. It's in this only. Multiplication, division, modulus. When you get one or more modulus or a modulus and division and multiplication, whatever it is, you just go from left to right. It's not right to left. Huh? Boolean operations. What are Boolean operations? Huh? I didn't cover that in detail in the class. That is covered for today's lab students, and that will be covered for other lab students in this week. But I touched it. Huh? No, not shift operator. Huh? Increment. No, not increment operators also. Hmm? No, not bitwise. Huh? Someone was saying. Assignment operator. I gave this example to you. You remember this example? I told you, suppose x equal to y equal to 2. What did I say? I said first this 2 will be assigned to y, and then this same 2 will be assigned to x. Okay, so first this assignment operation is done, then this assignment operation is done. Okay, it's not like y is assigned to x and then 2 is assigned to y. No. The rightmost assignment is done first, then left one and left one. So here the direction is from right to left. So there are very few operators whose direction is from right to left. Most of the operators' direction is from left to right. Okay? This is simple. Fine. Now I'll ask you one question. Suppose increment operator, decrement operator, I didn't cover in the lectures, but they were not covered in last week's lab, right? Today's lab they are covered, but not for all. Okay, so there are other sections we have tomorrow. All right. So let's just discuss this. Suppose I say 2 and 5 greater than 4. Now what is the result of this? Which one will be performed first? This one or this one? I mean logical AND or greater than? Why? Why should, okay, now suppose I say 5 greater than 4 and 2. What will be performed first? 5 greater than 4. Logical AND. Earlier someone was saying left to right. You see, left to right formula will work only if you know the different operators are of the same precedence. If they are not of same precedence, left to right, right to left does not work. You need to see, first you need to categorize operators into which first two sets. So whenever you are given operators, in an expression, you need to first perform, first step is classify them into higher and lower order operators. It can be more than one order. It can be 3 different orders. Whatever it is, first classify them like that. Okay, and then let me move it here. Then next step is within same level operators perform left to right or right to left evaluation. Sorry, my writing is not good. I will, before uploading, I will correct it and upload neatly. Or right to left evaluation depending on the operators. Okay, so if we take any of the previous examples, for instance, if I take this 20 divided by 8 into 4 plus 6 divided by 3. So first, what should I see? What all operators are given? Division, multiplication, and addition. So I write division and multiplication in one level and then addition in another level. Okay, first I divide them into levels. Division and multiplication are of one level, addition is in a lower level. Okay, now within division and multiplication, they go from left to right. Most of the operators go from left to right except three. I will tell you what those three are. One is assignment, others I will tell you. But usually left to right. Okay, so now within division and multiplication, it is left to right. And addition, left to right. Okay, so first you perform these operators, these operations. Okay, take left to right only among these operations. Okay, this is division, left to right, then multiplication, left to right, addition I will do later. Division, left to right. Okay, perform these operations, you get some values, then lower level operations, addition, perform that. Here there is only one addition, so just perform that. Okay, so first level, separate the operators into different levels. And now within each level, check whether it goes from left to right or right to left. That's all. Fine? Any doubts? Please ask if you have any doubts. Okay? You can stop me in between also. Don't worry. I think this is straightforward. Okay? Because you already know this. I'm just elaborating the reasoning behind that. Alright. Now within these two, first we need to know whether they are at the same level or not before we even say left to right or right to left. Alright. One is logical and one is a logical operator. Another one is a relational operator. Okay. Do all the logical operators, are they of higher precedence than relational operators or lower precedence or of the same precedence? We don't know. So there is something called operator precedence chart. Okay, before I show you that, let me ask you this another simple question. Suppose I take this 5 greater than 3 greater than 2. Now what is the value of this expression? 1. First, they are of the same precedence. That makes our job easy. Now only you need to think whether it is left to right or right to left. Most of them are left to right. This is left to right, which means I should perform this first. Okay, and then this next. So what is the value of this? 1. What is the value? Now the value of this is 1, which means what are we doing? 1 greater than 2. We are comparing that. So is 1 greater than 2? No. So what will be the output? 0. Suppose if you are doing from right to left, then what will happen? 3 greater than 2. What is the value? 1. And then 5 greater than 1. 1. Then output will be 1. You see, just by changing the order, the output is changing. If you are going from left to right, the result is 0. If you are going from right to left, the result would be 1. So the order is also very important. Okay? Don't think, okay, I found out which is a higher precedence operator, which is a lower precedence operator, now I can solve it. No. Again, within same precedence operators, you have to find out left to right or right to left. That is important. Okay? So here it is left to right. So the answer is 0. Fine? Okay. So now let's look at operator precedence chart. Now some of these operators are not yet covered for you. Don't worry about them. For instance, this first one, structure member, and another thing. Usually when the expression is quite long, or if you are not sure which operation, suppose you type something, now you're not sure in which order it will perform the operations. So rather than worrying about all that, you just put brackets. Okay, brackets will sort of override all operator precedences. Okay, now this is actually left to right, but I can make it right to left by putting these brackets. Now this will be forced to be right to left. All right. So that is why even if you don't know operator precedence, take the help of brackets to enforce the order which you want the computer to follow. All right. But if someone else has given you the expression and is asking you to evaluate, then you need to know a bit of operator precedence, right? So now, so these operators, those will be covered when we discuss pointers. Okay. So don't worry about these. Increment and decrement, they will be covered for some, it is already covered, for others, it will be covered in the remaining lab sessions. Alright, so increment and decrement, and then plus, minus, logical, not, bitwise. You see these lines, they are speaking of higher precedence. So here the precedence is going from high to low. The above ones are of a higher precedence, and as you keep going below, the precedence keeps decreasing. The priority keeps decreasing. Okay. Now all the operators within the same level, they are of the same precedence. Okay. Now if one or more operators are of the same precedence, what do? You need to find whether it is left to right or right to left. That's all. So first, let's look at these. These we know: multiplication, division, modulus. They are of the same precedence, and they are of a higher precedence than addition and subtraction. That is clear. Okay. And then bitwise operations, they are of a lower precedence than addition and subtraction. And then comparisons, relational operators, they are of a lower precedence than bitwise operations. And then within comparisons, within relational operators, again equal to and not equal to are of a lower precedence than other relational operations. Okay, we looked at 6 relational operations, out of which these are 4 and these are 2. So 4 relational operations are of the same precedence, and then next 2 are of a lower precedence. Then we get bitwise AND, then bitwise exclusive OR, then bitwise OR, inclusive OR, and then logical and then logical OR. So now, if you go back to this expression, which one will be performed first? Greater than. Relational operations are of a higher precedence than logical operations. Okay, so 5 greater than 4 is 1. 2 and 1 is what? 1. It is true. 2 is considered as true. 1 is considered as true. True and true is true. So that is equal to 1. Okay. Similarly here, this will be performed first. 5 greater than 4. That is 1. Again 1 and 2 is again 1. Okay. Alright, and then conditional expression, this is covered to you previous labs, right? Conditional expression, ternary operator, this is covered. This is lower of a lower precedence than logical order. And then assignment operators. Usually assignment operator is considered to be of the lowest precedence, but there is one more just below assignment operator, that is called comma operator. This is covered in today's lab. No. Okay. Don't worry. That is not. It's okay even if it is not covered. Others are important. So that is why now it will be clear to you why no matter when you have LHS and RHS, okay, say x equal to some very long expression, some y plus something divided by something multiplied by and logical and bitwise or whatever, very long expression you have on the right side. All right. Although when I say x equal to something, some very long expression with different kinds of operators, whatever it is, this is also an operator, assignment operator, these are also operators, all right? But we are usually assured that the RHS is evaluated completely and then that value is assigned to the LHS. Why is that happening? Because assignment operation is done at the end. Why? Because assignment operator has the lowest precedence among all operators. If you ignore comma operator, for a moment forget about comma operator, the last one. Other than that, assignment operator is of the lowest precedence. That is why no matter what complex and complicated operations you have in the RHS, all of them are performed first before any assignment is done. Unless you put brackets around assignment. Okay? That is why assignment operation is of the lowest precedence, because it should work similar to our understanding of like mathematical assignment. Alright, first we evaluate the entire RHS, then assign it to LHS. Okay, so that's the point. Yeah, so this is clear, and this chart is available in the sheet which I showed you last time. See reference card. So this is available here. Okay. So this reference card is very useful. If at all you forget something, you want to refer to something quickly, just use this. Fine. All right. So yeah. So now, no matter how long expression is given to you, you should be able to sort of sort it. So let me just give a very quickly some arbitrary random expression. 6 and 4 bitwise odd 5 minus 22 divided by 7 mod 8 right shift 2. Okay, so first you list all the operators: logical and, bitwise odd, subtraction, division, modulus, right shift. Okay, now divide them into different groups based on their hierarchy. All right, so first, what different categories of operators we have? Logical operator, bitwise operator, arithmetic operator. Yeah, mostly these three categories. All right, so we know that arithmetic operators are of a higher precedence, right? So let's just quickly see. Okay. So arithmetic, division and then plus minus. Division is of the highest precedence among these operators, division and modulus, and then minus, and then bitwise right shift, and then bitwise or, and then logical AND. These are the operators which we used. Fine. So let me write down. So first, let me mark the operators of the same precedence. Not same precedence in the sense, first division. This is of the highest precedence. This is also of the same precedence. Division and modulus. Okay, and then subtraction, next level. Okay, and then bitwise right shift, next level, and then bitwise odd, and then logical AND. Okay, now we have only two operators of the same level. Now this is from left to right. Okay, so first perform these two. So this division came first. So 22 by 7, this is 3. 3 mod 8 is 3 only. Okay, so this expression is done. This expression value is 3. Fine. Then next one is subtraction. So 5 minus 3, 2. So this expression is also done. Next, right shift 2, right shifted by 2 times. Right shift means dividing by 2. Okay, left shift means multiplying by 2. So when 2 right shift 2 means 2 is shifted to the right 2 times. What does it mean? So first 2 is converted to its binary form 1 0. Okay, when I do 2 right shift 1, which means this 1 0 is shifted to the right by 1 position, which means this 0 is gone. You are left with only 1. So 2 right shift 1 means 1. Okay, now instead of 2 right shift 1, if I say 2 right shift 2, then what happens? I shift the binary form of a number to the right by 2 bits. Okay, which means these 2 bits are erased. So you are left with only zeros, which means 2 right shift 2 means 0. Okay, so 2 right shift 2 means 0. So this entire thing now becomes 0. Now after right shift, next one is bitwise OR. Okay, so this one I should perform this 4. Sorry, let me put it like this. So this portion value is 0. So 4 or 0, bitwise 0. Okay, which means what is first? You need to convert these numbers to binary representation. 4 binary representation is 100. Zeros binary representation is as many zeros as you want. Bitwise OR means you bit by bit you perform the OR operation. This is not exclusive OR, this is normal OR. Okay, so 0 or 0 is 0. Again 0 or 0 is 0. 1 or 0 is 1, which means this is 4 only. So this 4 or 0, this value is 4. Okay, now finally 6 and 4. 1. 6 is true, 4 is true, true and true, 1. So final answer is 1. Okay, that's it. So if this kind of question is asked in the exam, we will provide this chart for you so that you don't need to break your head, you don't need to get confused which one came first and all that. So this chart will be provided to you and you can refer to this chart and perform whatever simplification you need to perform. Okay, fine. Yeah. So this AND is logical AND. In logical AND, it is like it deals with true or false, right? P and Q. P is true, Q is true, P and Q is true. So here you have not statements, but you have numbers. But how do you relate numbers with true false values? Like I said, any number other than 0 is considered to be true. Only if it is 0, it is considered to be false. So since 6 is non-zero, 4 is non-zero, it is like true and true, true. Even if it is a negative number, it is considered to be true only. Yeah. Okay. Fine. All right. So this is done. Okay. Now let me. Okay. So any doubts so far? No doubts, right? Done. Operator precedence is done. You need to put some time. Just try out some different kinds of operations. You just code something and then see what kind of result the program gives, and then you analyze why is this giving me this output, right? You just look at the chart and then try to analyze why the code is giving you that output. So try out some codes on your own. Give complex operators sequence, complex expressions, play with it. Okay, fine. Then in the okay, so here, if you remember, I showed you this kind of a diagram in one of the beginning lectures, initial lectures, right? There is an input, there is a processing, and then there is an output. Fine. So this diagram is basically translated into this code, or you can say vice versa. This code can be translated into this diagram. So basically, what is this diagram doing? You just take two numbers as input and then add those two numbers, store it in a variable called sum, and then print sum. That's it. There is a start state and then there is an end state. Okay. So what is this kind of diagram called? You all know this. Flowchart. It's basically a flowchart. Okay. Any program has some logic, and anything which is logical, any algorithm basically can be converted into flowchart. So if you can translate your thinking into a flowchart diagram, then it will be easier for you to translate the diagram into a code. All right. So you can think like this. Okay, I need to take two numbers, add them, and then print the output. So the steps will be like this: input number one, number two, then add both of them, store it in a variable, and then print that variable value. Now you have broken down your thinking, your algorithm into some discrete steps. Now take each part and translate it into code. So start means the entire template of the program, include stdio.h, int main, brackets. That is your start. All right. And then input number one, number two. This step I need to perform. How do I take two numbers as input? Scanf. Okay. So scanf. Okay. Even before that, we need to declare them. Okay. So declare them and then take these two numbers as input. And then operation. Perform addition and store it in a variable. So the operation is converted into this command, this statement, sum equal to number one plus number two, and finally print sum. So you have printf command, use that. End means it's like return 0. That's it. So you sort of translate your algorithm into a flowchart. So any coding, any good coder, if you are really a good coder, you should not immediately start typing. That doesn't make you a good coder. A good coder is one who, on writing the program works 100% accurately, 100% successfully in the very first go. You should not come back to the program to correct it. If you are doing it, it means you are not a good coder. It means you have a long way to go. Now, how will you write such programs? How will you write such codes? The best way is, first you translate your algorithm into a pseudocode. Pseudocode is something in between natural language and in between a complete accurate programming language. Okay? This is a kind of a pseudocode. So pseudocode is somewhere in between our language and computer language, and pseudocode helps you in translating your thought process into programming language. In between this stage is very important. It will help you a lot. Okay, so you need, even if you don't draw all these diagrams, these boxes, you can just write your pseudocode just like this. Okay, input number one, number two, then sum equal to number one plus number two, then print sum. Just these three statements, if you write, that's your pseudocode. It looks like code, but it is pseudo because it cannot be executed on a real computer because it is not having the exact syntax. At the same time, it is not a complete natural language thing because it has some aspects of a code. All right. So pseudocode is the best thing. So first, always, no matter how much urge you have to code and test your algorithm, don't do that. Always first translate your thought, your algorithm into a pseudocode on pen and paper, and you should do a dry run. Okay, suppose I'm giving this input, then this step is done, then this step is done, and finally this will happen. Once you do a dry run, once you are sure, okay, my code is perfect, then you actually translate that pseudocode into code on paper, actual code with the complete syntax. Then you just copy it into the computer. Okay, so all the thinking, everything should happen on pen and paper, not in front of computer. Once you sit in front of computer, by then all thinking should have been done. If you are doing it on computer, okay, I type something, something went wrong, again I think something, I do something, that is a very bad way of coding. Okay, programming is a way of thinking. So focus more on thinking, not on syntax. That you will learn after some practice. But the core part is in this algorithm. Okay, so put more time on algorithm, put more time on pen and paper. Finally, you just need to copy your code. Before that, you should be sure your code will run 100% before I put it on computer. So you should practice like that. Okay. Now, so this flowchart, this is simple. Okay, please, can we have some silence? Thank you. So this flowchart, you know the symbols of the flowchart. Quite simple. There are basically 5 symbols, right? One is oval shape. Oval represents either start or end, and then arrows. A line is a connector that shows relationships between any two shapes, and then parallelogram refers to input or output, and rectangle refers to some process. So that is happening on the CPU. It's not taking any input from external device, or it is not printing anything to the external device. Whatever is happening on the CPU, process that is represented using rectangle. Finally, diamond shape, that is for branching, like if else. All right, if it is true, it takes one direction. If it is false, it takes another direction, like that, right? That's all. So this is a flow chart, quite simple. Now let's take an example. So let's imagine, some, say you are editing a web page. All right, there is some current state of the web page. Now, say you edit the page. Okay. Now, if was your edition modified by others? If yes, do you accept that modification? Yes, then the page is done. You update the page. Okay. Suppose it was not modified by others. Then you made a modification, others did not modify anything, you just update the page. Okay. Now, suppose you made a modification, then others also made a modification, and you don't accept that modification. All right. Then you discuss the issue with the other person. Okay. Now, do you agree with the other person? No. Again discuss. Again, do you agree? No. Again discuss. You continue this process until you agree with the other person. Only when you agree with the other person, then you edit the page. Again, no one else should modify it. Then you update the page to the new page state. Okay. So there are a lot of ifs and else in this process. All right. If something is yes, you take one direction. If it is no, you take another direction. So you see the boxes. So if else are represented using diamond boxes. Only these will have yes and no branches branching out. Others are just processing. You are editing the page, right? Or this is like start. Previous page state you started with, new page state you ended with. Okay, that's it. So this is like an algorithm. So before you do anything, before in this particular case, before you start coding, you are setting down your algorithm. Okay, these are the steps. In this case, what will I do? In that case, what will I do? If this is true, what will I do? If this is false, what will I do? Then again I will branch out. Again I will branch out, like that. You see, here there is a branching out. Yes, no. Again, here there is a branching out. Yes, no. All right. Again, here there is a branching out. Yes, no, and so on. Fine. So this is like if else. Okay. So now if you look at if else structure, it looks something as simple as this. Oh, I am seeing a different. Okay, it's stuck again. I don't know. This is Linux. Ah, thank you. Yeah. So if else structure is quite simple. Um, you check for some condition. If the condition is true, one block of code will be executed. If the condition is false, another block of code will be executed, right? So which block of code will be executed? Whatever is there under the if condition, if it is true. If it is false, whatever is there under the else condition, that will be executed. As simple as that. So this is the if block, or let me put it like this. This is the if block, and this is the else block. Okay, quite simple. So you can sort of translate your code into a flow chart where you have these diamond boxes, where if it is true, it will take one direction, if it is false, it will take another direction. If it is again true or false, it will take another direction. You can do like that, and that will give rise to nested if else kind of a structure. So this is one example. So this is like nested if else. Say for instance, if we want to maintain our speed, yeah, silence please. If we want to say maintain our speed between say 70 to 75, now what one can do? Suppose if the speed is greater than 80, all right. If it is true, you slow down, all right. If it is false, now speed is less than 80. Now within that, is it less than 70? If it is less than 70, speed up to 75. All right. If it is false, that is if it is already greater than 70, you need not change. So basically, not 70 to 75, we want to maintain it, between 70 to 80, we want to keep it around 75. All right. So in that case, there are multiple if else conditions. Okay. So how do I write this code? So I say if speed greater than 80, okay, then slow down. All right. Else, there are two ways of writing it. I can say else if speed less than 70, speed up to 75. Okay. We will use nested also. Else, don't change. Okay. This is one way of writing it. Else if in the last and else in between. No. Else, you see, it's simple. Else means everything else. See, for instance, it's like I want to give marks to say A, B, or no one else. Suppose I want to say like that. I want to give marks only to A and B, A or B, but no one else. Now, one way of writing it is if it is A, give marks, or if it is B, give marks. But if it is anyone else, don't give marks. How do I write that? If I put else before, suppose if I say if it is A, give marks. If it is anyone else, don't give marks. Then even B will not get marks. So first I should cover the cases which I can list. Now anyone else means it can be 100 people, 1000 people, million people. So all those cases I am pushing to the last case. Right? If I bring them in between, then even the original cases which I want to consider, they will also get lost in this. That's why if you notice in else, we don't give any condition. Only in if we give a condition, in else if we give condition, all else ifs we give condition, but in else there is no need of condition. Only if all the above conditions are not satisfied, you just do the remaining. That's all. Okay, so else is like a general. Yeah, why is there so much disturbance? Just give me a couple of minutes, we'll close. So there can be many conditions of which you can't list everything. So you just push all these conditions into like else condition. All right. So that should go at the end. And there you need not specify the condition explicitly. You should not specify. That's it. Okay. Only if these conditions are not satisfied, it will happen. Another way of writing it is if speed greater than 80, don't change or slow down. Else, now I can make it a nested if else. Within this else, like this is one way of writing. In this else, I can write if else. If speed less than 70, speed up to 75, else don't change. Okay? If it is a single statement, you need not put brackets, but I am just putting brackets so that there is no confusion. Okay? This is another way of writing it. So this is nested if else. Okay? Fine. Let me just finish with one more diagram. You will understand. Okay. Finally, if there is a chain of if else statements, if this, do this, else if this, do this, else if something else, do this, else if something else, do this. It's like simple. If it is small a, print 97. If it is else if it is small b, print 98. Else if it is small c, print 99. Else if it is small d, print 100, and so on. So there is a sequence of if else if kind of a thing. So that will look like this, right? If this condition is true, you execute this block. Else, if this condition is true, you execute this. Else, if this condition is true, execute this, and so on. So there is a sequence of if one, first if, and then else if, and so on. Finally, it will end with an else. That's it. If all these conditions are false, it will come to block n plus 1. Here you don't see any new condition n plus 1. Only n conditions you have, n plus 1 blocks you have. So the n plus 1 block is the else block. It's not necessary that you should have, it's not compulsory that you should have it. You can have it or you need not have it. You can stop with if, or you can stop with else if, or you can stop with else. But you cannot have else if or else without an if before. That is compulsory. Okay, so this thing we can implement it as a chain of if else statements, or we can implement it using something called switch statement. So switch, it is probably covered a bit for today's lab session. It will be covered for others in other labs. I will also cover it in the next lecture. Okay. Okay. Just so mid-exam, the syllabus I posted on Discord in the doubt section. It is up to switch statement. From the beginning, binary conversions and complements and all that, up to if else, switch statements, all that. And second thing, you will have all kinds of questions. You will have objective. You will have like fill in the blanks. All kinds of questions you will have. Yeah.